Okay, from our review, I can see that we quite don't know how to translate the words into inequalities, so we'll review that first. But we're going to solve today multi-step inequalities. Before we get to that, though, let's review how to graph these things. So this is less than. And we could, English equivalent of saying less than would be at most, no more than.
A lower number than.
This one is less than or equal to. And we could I don't know another English equivalent.
Maybe lower, maybe the same.
Okay. Greater than. Actually, I think this phrase at most should be over here. At most. Okay, greater than equal to. This could be at least. So that makes the value the smallest possible. So if I wanted to graph x is less than 2. Put 2, what's to the right of 2?
1, 3.
3, and to the left? Open or close circle?
Open.
Open, and go which way?
The right. I meant left.
Left. Because I'm thinking a number smaller than 2. What if I had negative 3 is less than or equal to x? What's something that I should do?
Close the circle.
I will need to close the circle, but before I get to that step.
Oh, you need to make the variable on the left side.
Yeah, I flipped the whole thing around and notice it's pointing towards the negative 3, so it still points towards the negative 3.
You're having a lot needed today.
So, I don't know. It might be because of shouting yesterday. To the right of negative 3 is,
You sure did that.
Negative
and to the left,
2. Negative 1.
closed or open,
Closed.
and going which way?
Why is it negative 1?
It's going.
Oh, negative 4, sorry. Thank you. And going which way?
The right.
To the right. Okay, it's getting bigger. So we want to remember that. This is one we didn't do yesterday. Suppose I say x is not 1. So I put my 1 here. To the right is 2. To the right is 0. Our left is 0. Open circle, because it can't be 1. But then I go both ways. So that one's a new one. And then we'll get into solving these multi-step equations. Wow, I was really nice to you as far as homework. I cannot believe that. It's 156. That can't be right.
You can, and it will be right.
Would.
Where's the water when we get, even if we do what's wrong?
Okay. Now, let's go to solving these things. Yes. Okay. Not handy. I'll have to print another one. You can pull it up on your email if you have a thing and put in 2741 and give me 10 cents. All right, so let's say we're solving this. We don't necessarily need a wall. It might get confusing, but we do want to make sure that we are staying on one side. So these x's are on the same side, so I combine them, bring down. Now what do I do?
Minus the 4.
So I get x equals
1.
good. And when I go to graph that, 1, 2, and 0, open or closed?
Closed.
And go which way?
Right.
Good. Let's say I have something like this.
Distribute.
Okay, so what do I get?
3x, negative 4x, and plus negative 12, and just negative 12. And you combine the x's.
And what do we get?
X.
Careful, negative x. Now what?
Plus 12 for f12.
Okay, so we get negative x is 16. Don't drop that negative because 3 minus 4 is negative 1. Now I have a negative here. The x is not alone yet. So to undo a negative, we're going to either multiply or divide by negative 1. So when I multiply or divide by negative, what do I have to do with this?
Switch it.
Switch it around. That's going to be a very important thing. Like, guarantee you guys would do well in solving this, except some of you are going to forget that negative and what you need to do. So do not be that bonobo. Alright, so we have a negative 16, a negative 15, and a negative 17 on the left. And open or close circle.
Open.
And go
To the left.
left. Okay? We'll just do a couple more examples. Let's see here. Let's get some fractions in the mix. I know how much you guys love fractions.
Kill me.
How do I solve that one?
Multiply the 2. Oh, no, you have to make it from backwards to 6.
Yeah, multiplied by 6. Now I need to be careful to distribute to every term. Okay, so first term.
3.
The 6 cancels to a,
2.
careful.
Give me 3.
Okay, so the 2 cancels the 6, gives me a 3, and 3 times 3 is?
2.
3 times 3 is 9, plus, does anything cancel?
No.
So I get
69.
6x is less than or equal to
2.
2. Now we subtract the 9, so we get 6x is less than or equal to negative 7. Do I need to switch this? Because I subtracted 9.
No.
No, only when I multiply or divide by a negative, and then I divide by 6. Now, if I'm graphing this, I want to know that this is just past negative 1. It's not quite to negative 2. So if this is negative 1, and this is negative 2, negative 7, 6 is probably closer to the 1. Okay, so I'll just put this little extra hash here, less than or equal to, boom, going that way. See how I graphed that? I estimated where it is. All right, let's say I have x minus 2.5 is less than or equal to 1/5. What should I do before I begin?
Make the 2.5 over the fraction.
Yep, so I get 5 halves there. Now what do I do?
Oh, then you get rid of fractions.
So I multiply by
10.
10. Okay, so we distribute that 10 and I get 10x. The 10 cancels with 2, leaves a,
5.
and 5 times 5 is,
25.
notice where that's coming from, is greater than
2.
2. Now I add the 25, get 27, and I divide by 10. X is greater than 27 tenths. You could also write that as 2.7. Okay? We're going to continue in our notes on some word problems, but I'm not going to record that portion because it just doesn't make sense because I'm not going to write the word problems. So I do want you to go to page number 144. And then get your whiteboards ready so that you can do a bunch of problems.
My favorite.